Okay, so we have Pure Free January 2022 with Mindful Maths. Let's take a look at this paper. Okay, question 1. 4 marks, nice and simple. So let's start by having a look. So find using calculus. You know this is differentiation or integration. The x-coordinate of the stationary point. So you know the stationary point is found when we do the differential equal to 0. So having a look at this straight away, I know first off we have a product rule. 2 functions multiplied together. So v du plus u dv. I'm going to choose one is my v, one is my u. Now it doesn't really matter for product rule which one is which, however in quotient rule it does. So if my v is 2x plus 5, dv is 2. If the differential is 2, my u is e to the 3x. The differential of u is e to the 3x multiplied by the differential of the power, which is 3e to the 3x. So v du plus u dv. So I'm going to have 3e to the 3x multiplied by 2x plus 5 equals 2e, sorry, not equals, plus 2e to the 3x. So this is what dy by dx equals. Now, if I put this equal to 0, I get 3e to the 3x, lots of 2x plus 5, plus 2e to the 3x equals to 0. This is going to enable me to find my x-coordinate of my stationary point. Now, if we wanted to, we could factor out an e to the 3x. We're going to get 3 lots of 2x plus 5 plus 2 equals 0. So we either have e to the 3x equals 0 or this bracket equals 0. So if we expand this bracket out, we're going to have 6x plus 15 plus 2 equals 0. 6x equals negative 17. X equals negative 17 over 6. Now, as we know with the e to the 3x, you know from the graph that looks like this, that it will never equal 0. So we can reject this or discard it. We don't need to worry about that. So our x-coordinate is minus 17 over 6. Right, double check the question. Has it asked for coordinates or just the x-coordinate? And it's just said the x-coordinate. If it wanted the y-coordinate as well, you would substitute that x back into the original equation. Okay, question 2. Show that the equation 8 cos theta equals 3 cosec theta can be written in the form sine 2 theta equals k. Okay, so 8 cos of theta, there's nothing we can really do with that, so we can just write that. Cosec, we know the middle letter is s, so we know that that is 3 times 1 over sine theta. Now, some people like to just go ahead and rewrite that as 3 over sine theta, that's fine. So we're going to have 8 cos theta multiplied both sides by sine theta equals 3. Now, we know that 2 sine theta cos theta is equal to sine of 2 theta. So we can factorize a 4. So we have this in the form 2 sine theta cos theta equals 3. We now have 4 sine theta cos theta, 4 sine 2 theta equals to 3. So therefore, sine 2 thetas equals 3/4. So k equals 3 over 4. Nice and easy. Part B says, hence find the smallest positive solution. So we want the smallest positive solution, degrees, 1 decimal place. So the first thing I need to do is make sure my calculator is in degrees. Let me just change it because it normally is in radians. And then let's have a look. So if I have sine of 2 theta equals 3 over 4, inverse sine 3 over 4, shift sign 3 over 4, and it's going to give me 48.59, etc. I just want theta, so I'm going to go ahead and divide the answer by 2. And because it just wants the first smallest positive, I'm going to get 29. Then I don't need to worry about, doing cast or anything like that. I just want the first one. 1 decimal place is 24.3 degrees. Nice and easy, 5 marks. Okay, question 3. Part I. So, integration of 2x minus 5 to the power of 7 with respect to x. Okay, so when we integrate, we increase the power by 1, which is 8, and divide by the new power. Okay, so we're going to do that to the bracket. Then we know we have chain rule here, so we also need to divide by the differential of the bracket. So what that means is if I was to differentiate 2x minus 5, this is going to give me 2. And I also do need to divide by that. It's the same as doing 8 times 2 on the denominator. So my final answer is 2x minus 5 to the power of 8 over 16 plus our constant of integration. So plus c. Nice and easy, 2 marks. Okay, part II. So we want to integrate between 4 over 3 and 0, 4 sine of x over 1 plus 2 cos of x with respect to x. And it wants it in the form ln a. So let's have a look at this. First of all, I'm looking at this and thinking, it's a quotient rule. But remember, we don't know how to do quotient rule for integration. We don't have a such thing as a quotient rule yet. What we have been working on in Pure 3 is assumption. So I think to myself, okay, the most complicated is the denominator. And what would we assume? Y equals what would integrate, and forget about the 4 sine x, to 1 over something. We know that y of ln integrates to, differentiates to 1 over 1 plus 2 cos x. Now, we know when we differentiate, we also need to multiply by the differential of the bracket. What is the differential of 1? 0. The differential of 2 cos x is actually minus 2 sine of x. So that leaves me with minus 2 sine x over 1 plus 2 cos of x. Now, we don't want minus 2. We want... we want 4. So what do I need to multiply this whole thing by to get 4? Minus 2. So I need to do that in the original one. So I get minus 2. So what we've done is we've worked backwards. So I know that if I integrate this, this is my answer. So the integral of 4 sine x over 1 plus 2 cos x is in fact minus 2 ln of 1 plus 2 cos x. Okay, nice and simple. We don't need a constant of integration because we're putting in our limits. So now what we're going to do is some substitution. So let's go ahead and substitute this. And let's see what we get then. Now, if I'm going to substitute in, it wants it in the form of ln. So this ln I'm just going to keep here. I'm going to have 1 plus 2 cos of 4 over 3, all to the power of negative 2, because we know using the log laws we can do that, minus ln of 1 plus 2 cos of 0 to the power of negative 2. Okay, so inside the bracket, I'm just going to focus on what's inside the bracket. So I'm going to do bracket 1 plus 2 cos of 4 over 3 And then all of that, yeah, I'll put another bracket here so you can see, to the power of -2, okay, doesn't give me anything very nice. So when I put it into my calculator and I put all of this into my calculator, to the power of -2, I got decimals. Okay, this gives you a sign because to stop what you're doing and to work it out bit by bit. Okay, so what is cos of 4/3? Let's start there. So cos of 4/3, I know exactly what's wrong with my calculator, and I can't believe we've just done this. Right, what is this? Pi. Radians, see? Okay, radians. So step 1, change calculator to radians because it was in degrees from the question before. Happens to all of us, and these decimals should be a sure sign because it wants ln A, okay? So let's try again. Cos of 3/4. No, it's not. It's 4/3. Oh my golly. And it still gives me an awful answer. So I'm going to put this whole thing into my calculator one more time. Okay, so I've been sat staring at this for a minute. I've just realised my mistake. This is pi/3, guys. Please make sure when you copy down the question, you read it properly. This is probably one of the biggest mistakes. I even said pi. Okay, so now we're going to start again with our pi/3. So cos of shift pi/3 is 1/2. Okay, so now we know we're going to have ln of 2 times 1/2 is 1, plus 1 is 2, to the power of -2 is 1/4. And we're going to minus that from, now we know that cos of 0 is 1. So cos of 0 is 1. We're going to multiply that by 2. We're going to add 1. And then to the power of -2, we know is 1/9. So ln of 1/9. Now, when we take away, we divide. So we're going to have 1/4 divided by 1/9, which gives us ln of 9/4. There we have it. Nice and simple. If you double check, you read the question. If you're ever going wrong, this is probably where you're going wrong. And the reason why I left this on here instead of rewinding back and fixing my mistake at the beginning is to show you that it does happen. It is okay. You just have to notice that actually when you're getting decimals, there's clearly something wrong because it tells you that A is a rational constant to be found. Okay. Question 4. Now, we normally get either these types of questions or the one where we have the logs and the straight lines. So it's kind of either or. I always like to think these questions are a bit like common sense. We need to make sure we read everything. So the growth of a weed on the surface of a pond is being studied. The surface area of the pond covered by the weed, A millimeters, is modelled by the equation. So we know that the surface area is A. P is a positive constant, so we need to make sure that we get P as positive, and T is the number of days after the start of the study. So, given that our A is 30, of the surface of the pond was covered by the weed at the start of the study. So at the start of the study, we immediately know that T equals 0. It then says 50 metres squared of the surface, so again, this is our A, was covered by the weed T days after the start of the study. Show that P equals 2.4. Okay, so we're going to use the first bullet point because the second one's not going to give us really any information. And all I'm going to substitute is 30 equals 80. Now remember, we're trying to find P. E to the power of 0.1.5 to the power of 0 over PE to the 0.5 to the power of 0 plus 4. Now we know anything to the power of, so we're going to have 80p over p plus 4. Oh, sorry, forgot the 0. Right, so 30 lots of p plus 4 equals 80p. So 30p plus 120 equals 80p. So 50p equals 120. P equals 120 divided by 50, which is 2.4. therefore shown. So now we know P is 2.4. And now wants us to find the value of T. Okay, so the value of T. So we know 50 equals 80 lots of 2.4 times e to the power of 0.15t over 2.4 times e to the power of 0.15t plus 4. Okay, so if I expand this out, what I'm going to have is 50 times 2.4. I'm going to have 120 e to the power of 0.15t plus 200 equals 80 times 2.4, 192 e to the 0.15t. Now I'm going to take away 120 e from both sides. So minus 120 is 72 e to the power of 0.15t. Divide both sides by 72. So I'm going to get 25 over 9 equals e to the 0.15t. Now I'm going to ln both sides. So I'm going to get ln of 25 over 9 equals 0.1.5t. And then divide both sides by 0.15 to get my t. Now it says 1 decimal place. So ln of the answer, and then divide that by 0.15. I'm going to get t equals 6.811. It wants 1 decimal place, so t equals 6.8. Okay, so nice and easy. So it then says the weed grows until it covers the surface of the pond. Find, according to the model, the maximum possible surface area. So if we want the maximum possible surface area, I like to think of it like this. I put in the biggest value of t. So I'm just going to assume, I'm going to put it into this. So just assume t equals 1,000. Okay. What happens when t equals 1,000? Well, actually, what you find is you get e to the power of 0.15 times 1,000 is a really large number. Okay, so if I do 80 times 2.4 times e to the power of 0.15 to 1,000, because if we think if it's been 1,000 days, this should give us an estimate of what's going to happen plus 4. Because what we're doing is we're assuming that time goes on to infinity, but instead of using infinity, I'm going to put this into my calculator, and we know this is going to, when I put this whole thing into my calculator, I put it all in, it gave me 80. So we know as t tends to infinity, actually the area is going to tend to 80, so the maximum possible value is 80. Okay, question 5. So figure 1 shows a sketch of part of the curve with this equation. The curve cuts the negative x-axis at P, shown in figure 1. Show that the x-coordinate of P lies in this interval. So what we have straight away is numerical methods. So what I'm going to do is I'm going to let x equal minus 1.25 and let x equal minus 1.2 to see what my y values are. I'm literally going to substitute it into this equation. Now we know that this is continuous, so what we're looking for here is a change of sign. Now when I put this into the equation, I'm going to get minus 0.9 and 0.2. So change of sign and continuous. therefore we can say, therefore root lies in interval. Anything like that will be perfect. So that's a nice, easy for part A. Then it says the curve cuts the positive x-axis at the point Q, also shown in figure 1. Use the iterative formula with x1 equals 6 to find the value of x2, and by continued iteration. So this is really lovely. So what I like to do for B, is I put x1 equals 6 into my calculator to have something that says answer. What I'm then going to do is substitute, I'm going to put this in, and everywhere it says x to the n, I'm going to put ants, my answer, and then I'm going to get my x2 to 4 decimal places is 6.637. And then for part II, it says continued iteration, so I'm literally just going to keep pressing equals until it stops changing. So then I get x equals 6.4142. Nice and easy, 3 marks. Okay, part C. It has a maximum turning point at M. So we know when we differentiate this, we need to put this equal to 0. Using calculus, show each stage of your working. So I'm going to go back to the original of the equation. So we're going to get 6 ln 2x plus 3 minus a half x squared plus 4. I'm going to double check I've copied everything right. Okay, and let's start differentiating. So if I differentiate this, I'm going to get 6 over 2x plus 3 multiplied by the differential of the bracket. If I differentiate 2x plus 3, I get 2. And then bring the power down, which is minus 1 to the power of 1. Perfect. Okay, there we go. So I'm going to get 12 over 2x plus 3 minus x. Okay, this equals 0. So what I'm going to do is I'm going to move the x to the other side, 2x plus 3. I'm going to multiply both sides by 2x plus 3, so I'm going to get 2x squared plus 3x equals 12. Take away the 12, and now I have a quadratic. Okay, so I'm just going to use my calculator to figure this out, or you could use the quadratic formula. It really doesn't matter as long as, again, you're showing your steps. So I just go to menu, shift A. Okay, so I've got 2, 3, minus 12. So I get minus 3 plus root 105 over 4. When I press SD, this gives me 1.811. And then I get minus 3 minus root 105 over 4. And again, when I press SD, I get minus 3.311. Okay, x equals. Now let's take a look at these values to see which one we're going to accept and if we have to do any rounding. So, this is a maximum, and we can see here our x coordinate is positive. So we're going to reject the negative in this case. And therefore x equals 1.81. So 2 decimal places. And it hasn't asked for how many, but it has given this. So that will be enough to get you the 4 marks. Again, nice and easy, question 5. Okay, question 6. Show by calculus. Again, we're going to be differentiating or integrating that this is a decreasing function. So what I have here is quotient rule. Now remember, v is always the denominator, and it's v du minus u dv over v squared. So v is x minus 4, dv is 1. U is 5x minus 3, du is 5. So we're going to have v du, Okay, so v du is 5x minus 20 minus u dv, which is 5x minus 3, all over v squared. So we're going to get x minus 4 squared. Now, if we simplify the numerator, we're going to have 5x minus 20 minus 3, which is minus 20 plus 3. So we're going to get negative 17 over x minus 4 squared. Now, how does that help us to show that it's decreasing? Well, actually, we know for sure because x minus 4 squared is always greater than 0 or equal to. And obviously, negative 17 is less than 0. If we have a negative divided by a positive, we're still going to get a negative. So this tells me that the differential is less than 0, therefore decreasing. Okay, nice and simple. So the gradient is less than 0, therefore decreasing. Okay, part B. Find the inverse of f. So fx minus 3 over x minus 4. Now, everyone does this differently. What I'm going to do is I'm going to put y equals and then rearrange to get x equals. So I'm going to multiply both sides by the denominator, expand out, rearrange to get x's on one side and everything else on the other. Factorize out an x and then divide both sides. So now my inverse function, sorry, I've put differential for some reason, is 4x minus 3 over x minus 5. Again, this is GCSE stuff here. You would have done functions in GCSE. Okay, part C, I find f of x. Okay, f of x. So 5 lots of minus 3 over x minus 4. Now, in this case, our x is in fact our 5x minus 3. This is what I'm going to substitute into my function, okay, because it's a function of f. Okay, so what I'm going to do straight away to make my life easier is I'm going to multiply every single term by x minus 4. So if I do that, it cancels from here, it cancels from here. I'm now going to have x minus 4, x minus 4. So I'm going to have 5 bracket 5x minus 3 minus 3 bracket x minus 4 all over 5x minus 3 minus 4 lots of x minus 4. So now I can go ahead and expand and simplify. So 25x minus 3x is in fact 22x. Then I'm going to have minus 15 plus 12 is minus 3. Now, you might want to do this step by step. That's fine because there is a minus here, so watch out for that. Then we're going to have 5x minus 4x, which is just x. And then I'm going to have minus 3 plus 16 is plus 13. Perfect. Okay, so again, you don't have to do it that fast. You can write it step by step, but 22x minus 3 over x plus 13 is correct. Then the last one, it says deduce the range of f of f. So first of all, the range. We know that x has to be greater than 4. It told us in the question. So y equals 22x minus 3 over x plus 13. So first step, I'm going to put x equals 4 into the equation and see what we get. And I get y equals 5. So I know straight away that our function of x is going to have to be greater than 5 because it said x is greater than 4. Then again, what am I going to do? I'm going to substitute in a really huge number to see where this tends to. And I'm going to try 1,000. That is my go-to number to see what would be the highest point. And I get 21. I get y equals 21.71. Okay, I'm not convinced. So do you know what? I'm going to add on 2 more zeros into my calculator. And then I get 21.99. Okay, so we can see it's getting close to 22, but not 22. Okay, so I put in 1,000, then I added 2 more zeros in just to see. Now, if I wanted to, I could keep going. Let's make it 1,000,000, shall we? And let's see what happens. Even when I put in 1,000,000, again, I get 21.9997. Okay, so you can see it's definitely tending towards 22. So this is saying as x tends towards infinity, y is tending towards 22. So there'll be an asymptote there. So there we have it. There is the range. Okay, question 7. So we have a nice functions and modulus question. So here we see a sketch part of the graph, and it says state the coordinates of the vertex. Now, the vertex is what makes this modulus 0. This is when x is minus 7 over 2, and that is at the point where y is minus 10. So the coordinates is minus 7 over 2 minus 10. So that's nice and easy. Then it says solve using algebra. Now, remember, when we have a modulus, we need to solve 2 ways, okay, because it's been reflected. So number 1, we're going to do a half, lots of 2x plus 7 minus 10 is greater than or equal to a third x plus 1. And then we're also going to solve a half of, and then we're going to minus everything inside the bracket. We're going to multiply everything inside the module by -1. So in this case, we're going to have minus 2x minus 7 minus 10 is greater than or equal to a third x plus 1. Okay, so I'm just going to work on this. Okay, so we're going to have a half times 2x, which is just x. Then a half times 7 is 7 over 2 minus 10 is greater than 1 over 3x plus 1. So I'm going to have 2 over 3x, and then I'm going to have 1 plus 10 minus 7 over 2. Okay, so take away all the numbers. I'm going to get 15 over 2. If I divide that by 2 over 3, I'm going to get x is greater than 45 over 4. Okay, now the next side. I'm going to have minus x minus 7 over 2 minus 10 is greater than a third x plus 1. So I'm now going to have 4 over 3x. If I add x to both sides, is less than or equal to minus 10 minus 7 over 2, and then I'm going to minus 1 and get minus 29 over 2. Divide that by 4 over 3, and I get minus 87 over 8 is greater than or equal to x. Again, you can rewrite that as x is less than minus 87 over 8. Now remember, if you had have brought the x to this side, you would have had negative x's. When you divide by the negative coefficient in front of the x, you would have to change the sign, okay? So make sure you are aware of that. Oops. Okay. Then it says sketch the graph for the equation modulus f of x. Okay, so that means we want everything. It's a reflection in x-axis, okay? It's really simple to do. Basically, because we want the modulus of the whole function, it means that our y will never be less than 0. So anything below the x-axis needs to be flipped up. So your graph is going to look like this blue line. Now it is 4 marks, so make sure you write down the coordinates of the maximum and each minimum. It wants the coordinates of these two, because these two are now your minimums, and your maximum. Now you know this is going to be your positive y value of part A. So this is going to be minus 7 over 2, 10. Okay, and then where does it cross the x-axis? This is when y equals 0. So again, what we're going to do is we're going to solve this for y equals to 0. We're going to do it twice. So we're going to have half lots of 2x plus 7 minus 10 equals 0. And then we're also going to have a half lots of the negative inside the bracket, minus 10 equals 0. So we're going to have 2x plus 7 equals positive 20. So 2x equals 13, x equals 13 over 2, which is positive. So we know that's going to be over here, 13 over 2, 0. And then for this one, we're going to have minus 2x minus 7 equals 20. So minus 2x equals 27. So x equals negative 27 over 2, which again, negative 27 over 2 is going to go here. So I know I think you're provided a different graph or some sketches, but that will give you the full 4 marks. Okay, question 8. Oh, so we do have a log 1, but no graph. That's okay. So a dose of antibiotics is given to a patient. The amount of antibiotics, milligrams, in the patient's bloodstream, T hours, okay, x milligrams, T hours after the dose was given is fine to satisfy this equation. Show that this equation can be written in this form. Okay, so first of all, we know that log to the base a of b equals c means we can do a to the power of c equals b. So we can say that 10 to the power of 2.74 minus 0.079t equals x. Now, what do we know of the laws of negative? We know that this is 2.74 over 10 to the power of 0.79t. Be careful here, of x. So that is the same as multiplied of the negative of that. Okay, so we could actually, has it told us p and q are constants to be found? Give the value of p to the nearest whole number. Okay, so first of all, t to the power of 2.74 is 549.5, so that's 550, times, and then it wants the number of q to 2 significant figures, so 10 to the power of 0.079 is 1.2 to 2 significant figures to the power of t equals x. So there we go, nice and simple, we found it all out. So with reference to the equation in part A, interpret the value of the constant p. So what does that mean? That means that when t is 0, we're saying that there's 550 milligrams in the bloodstream already. Okay, so when t is 0, we're going to get 1.2 to the power of 0, which we know is 1. So how would we write that? We can just say, we know it's 550, but I don't think we have to go into that much detail. We can just say P is the amount of antibiotic. Now, because it says with reference to the equation, interpret, we need to make sure we're talking about the antibiotics in the patient's bloodstream. P is the amount of antibiotics in the bloodstream at the start. Perfect. Okay, when a different dose of the antibiotic is given to another patient, the values of x and t satisfy this equation. Use calculus to find the 2 significant figures, the value of dx dt when t equals 5. Okay, so this is completely different now. So we have x equals 400 times 1.4 to the negative t. So if we differentiate x with respect to t, what are we going to get? Now remember, this is the same as a to the power of x. When I differentiate that, remember, you need to remember this. What are we going to get? We're going to get a to the x ln of a. Okay, this is the rule. So we're going to get 400 multiplied by 1.4 to the minus t multiplied by ln of 1.4. Okay, so there we have it. Now, is there anything else? Oh, and we also need to multiply by the differential of the power. Now, minus t is negative 1, so that becomes minus 400. So now we're going to substitute t equals 5 because it wants to know. So I'm going to put in my calculator minus 400 times 1.4 to the minus 5 times ln of 1.4. Two significant figures. So let's see what we're going to get. Minus 400 times 1.4 to the power of negative 5 times ln of 1.4. I'm going to get minus 25.024 dot dot dot, which is minus 25 to two significant figures. There we have it. Nice and simple. Okay, question 9, part I. Solve the equation for 0 is less than x is less than pi. Step 1, radians. Okay, so we have this equation here. We need to solve it. So, what do I know that connects sec squared and tan squared? Now, I know we have to remember these. I always forget, but what do I know? I know that sine squared plus cos squared equals 1. Okay, I've just written it really shorthand. How do I get sec squared? Well, this is 1 over cos squared. So if I divide this all by cos squared, this is my easy one to do it. I get sine squared over cos squared, which I know is tan squared, plus 1 equals sec squared. So this is how I remember it. So now, instead of writing 2 sec squared, I'm going to write 2 bracket tan squared x plus 1, because that's what sec squared equals. Minus 3 tan x equals 2. I'm just going to put that in a little bubble. That's an easy way to remember it, by the way, because I don't remember all these. I have to work them out. So that's how I work them out, but I do it quicker in my head. So now I get 2 tan squared x plus 2 minus 3 tan x equals 2. So I'm going to have 2 tan squared x minus 3 tan of x, and then plus 2 and then minus 2. This is going to equal 0. So I can actually factorize out tan of x. So I'm going to get 2 tan x minus 3 equals 0. Again, you could use substitution and say let tan x equal y to make it easier. So I know here that tan x equals 0 and that tan of x equals 3 over 2. Now remember, it just wants between 0 and pi. So that's all I'm looking at. So first of all, x here equals shift tan of 0, which we all know is 0. But when does it cross again? It actually crosses. Does it include 0 and pi? Right, see, it doesn't include 0, it does include pi. So it's 0 and it crosses at pi, but we're going to reject this one here. Why? Because it doesn't cross, it doesn't want 0. Then shift tan of 3 over 2, delete 3 over 2. I'm going to get 0.9827, which is about here. Reflect that down here. This is out of my boundary anyway, so I don't really care about that. Okay, so therefore, x equals, what does it want? Decimal places, 3 significant figures. So we have pi and 0.983. There we go, nice and simple. Now, if you kept 0, I think you would have lost a mark. So please be aware of that, okay? And remember with tan x of 0, if you're not sure, think about the tan graph looks like this. And then looks like this. Instead of pi over 2, pi 0, etc., okay? Nice and easy, 4 marks. Okay, I do love trig. Right, II, Captain. Okay, so we've got to prove that this is equivalent to 2. Right, so first of all, left-hand side equals sine 3 theta over sine theta minus cos 3 theta over cos theta. Now, we want to show that this equals 2. So, here we go. What is sine of 3 theta? Okay, so first of all, let's see what we can do. Let's actually... Okay, I'm not sure if this is going to be the quickest way, but what do I know about sine of 2 theta plus theta? Because that's essentially what sine of 3 theta is, right? This is going to give me sine of 2 theta cos theta plus sine of theta cos 2 theta. Again, this is all in your formula sheet. Okay, again, what is sine of 2 theta? This is sine of theta plus theta, which is sine... actually, it simplifies to 2 sine theta cos theta plus sine theta. Now, what is cos of 2 theta? Now, using your formula book, I'm pretty sure it's it's either sine squared theta. I think it's sine squared theta minus cos squared theta. Let me check this. Other way round, guys. This is why it's always handy to check. It's cos squared minus sine squared. Okay, so we're going to have cos squared theta minus sine squared theta. Right, so I'm going to have 2 sine theta cos squared theta plus sine theta cos squared theta. Okay, so that's actually 3 of those. Minus sine cubed theta all over sine theta. Okay, so I can simplify this to 3 cos squared theta minus sine squared theta. Okay, what is over 1? Done. Okay, nice and simple. So that is the left-hand side. Minus. Now, what is cos 3 theta? This is the same as cos 2 theta plus theta, right? So this is going to give us cos theta cos 2 theta minus sine theta sine 2 theta, okay? What is cos 2 theta? We know this is cos squared minus sine squared theta. Oops. Minus sine theta. Now, what is sine of 2 theta? Is 2 sine theta cos theta. This is long-winded. So then I'm going to get cos cubed theta minus sine squared theta cos theta minus 2 sine squared theta cos theta. Okay, great. So I'll get cos cubed theta minus 3 sine squared cos theta. Now remember, this is all over cos theta. So I can cancel that. So I'm actually going to have cos squared theta minus 3 sine squared. Okay, so what does this give me now? So I'm going to get 2 cos squared theta minus minus plus 2 sine squared theta. Okay, this is great, guys, because what do we know about sine squared plus cos squared? This actually, in fact, equals 1. So we get 2 lots of 1, therefore is completely equivalent to 2, therefore proved. Wow. Okay, so that's how I would have done it, personally. And that's because I haven't remembered anything so that I can do this question just from the formula book. It is a bit long-winded. It's an 8-mark question, and we have completed this in literally 8 minutes. So it can be done even though it seems like a lot. Well done. Okay, and finally, the last question we have is question 10. Right, so x equals ye to the power of 2y. Show that dy by dx equals this. Okay, so if x equals ye to the 2y, we're going to differentiate x with respect to y and then flip it over. What do I have here? Product rule. So v du plus u dv. What does v equal y? The differential of y is 1. U equals e to the 2y. Is it definitely 2y? Yep. Du equals 2e to the 2y. Remember, because we multiplied by the differential of the power. So, v du is 2ye to the 2i plus u dv, which is e to the 2y. So now, dy by dx equals 1 over 2ye to the 2y plus e to the 2y. Now, now you can see here that what they've done is it looks slightly different to what we have. So now we need to manipulate it a little bit. So what do we know? We know that actually x equals ye to the 2y. So instead of writing ye to the 2y here, I can write 1 over 2x plus e to the 2y. Okay, that looks good so far. However, what have they done? They've multiplied everything by y to get y on the numerator. So if I multiply every single thing by y, what do I now get? And I get y equals 2xy plus e to the 2y. We know what e to the 2y is. It's x. So again, we're going to have y equals 2xy plus x. Now you can see they factorized the denominator by taking out a factor of x, and I do get 1 plus 2y. This is all manipulation. Keep referring back to what they want and see what you can do, okay? Remember, if we multiply everything by y, we're essentially multiplying by y over y, which is a whole one. So it doesn't change anything. Okay, that's great. Now it says, given that the straight line with the equation x equals k is a constant, cuts C at exactly 2 points. Now I'm looking at this, and if x equals k, x has to equal somewhere here, if that makes sense. Because we know it's an x equals, so it's like this. But if it crosses at 2 distinct points, it needs to be between this asymptote and this like bump here. So really we want to find, here we go. So find the range of possible values of k. Right then, so what do we need to do? Okay, so we know for sure that k is definitely a negative. So we could say k is less than 0. What we need to find is this part here. Okay? So we also need to look at where this asymptote is. Now if you think about it, this is where the gradient is going to tend to infinity. So actually, what would make this equal 0 on the denominator, where we'd have a mathematical error? This is actually where y equals negative a half. And then we'd have here x equals, x could equal 0, etc. So y equals negative a half. We're going to actually find our next x coordinate by substituting it into here. So x equals negative a half e to the power of 2 lots of negative a half. So we're going to have negative a half e to the power of minus 1. which you could leave like that, or you could write minus 1 over 2e, sorry. Okay, so then you have minus 1 over 2e. That is what our values of k have to be between. Okay, amazing work, great paper. Make sure you like and subscribe for more videos.